Good evening, Ravi Babu sir. Now, this class is meant for those students appearing for IIT JEE main examination or any other engineering entrance examinations like BITSAT, BITSAT, and Manipal, or whatever the engineering examination is there. For those students, this class is planned. So, the class is taken under the impression that you all know the basic concepts of straight line. And if at all you need the explanation of any concepts or any formula or whatever, you please place your comment or requirement in the chat box so that I'll see and I'll explain it. So, to begin with, the straight line, what I said, I am under the assumption that you all know the basic concepts. And I'm now presenting all the problems with a sort of revision first, with a sort of revision of all the concepts. And in the next session, we'll be discussing exclusively the previous questions. Today we will be understanding the problems concept-wise. But before that, let me tell you a faster writing of the line equation. What I mean to say, a trick to write the equation of a line using the slope. If you know this, it will be very much useful in writing the line equation from the slope within one step without using the formula like y minus y1 is equal to m into x minus x1 or whatever the other formula are there. So, if you understand this trick or technique or the short form to write the line equation, then it will be very much useful in the tangents and normals also. In the tangents and normals, you might be remembering in calculus, applications of derivatives, tangents and normals, wherever and whatever the problem is there in tangents and normals, you will have to find out dy by dx. At a particular point. Dy by dx, as you all know, according to calculus, it is the slope of the curve. It is a gradient of the curve. If you differentiate any curve, then whatever first derivative is there, it is termed as the slope. So, there also this short form is useful because everywhere you will get the slope in tangents and normals. So, follow this carefully. Very simple. That is, if you take a line equation, line is ax plus by plus c equal to 0. The standard format, everyone knows that. And its slope is minus a by b is a slope. Whatever is known to us, we have just modified it for our convenience to write the equation directly. So, and that particular line is passing through a point x1, y1. And that particular line is passing through the point x1, y1. Then how to write the equation of the line? Simple. Remember, multiply the numerator with x and denominator with y, and if you have minus there, put plus here. If you have plus there, put minus here. If you have minus there, put plus here. If you have plus there, put minus here. That is, reverse the sign in between. Is equal to, substitute the point, a x1 plus b y1. You learn this first. It will be comfortable while writing any line equations. Okay. So now let me take a numerical example so that you will be more comfortable with this application. That is, let me take a point. Minus 1, 2. And another point, 3, 7. I have taken 2 points there, 1, 2 and 3, 7. Now I want to write the line equation. Then simply write the slope. What is the slope? Slope is equal to 7 minus 2, 5 by 3 plus 1, 4. Now write the line equation. 5x, 4y, and you have plus there, put minus, is equal to, substitute this point or this point, whatever the point you substitute, you will get the constant, is equal to minus 5, minus 8, minus 13 is the line equation. Learn like this. Of course, you can apply y minus y1 is equal to m into x minus x1. You can apply y minus y1 is equal to m into x minus x1. But if you learn like this, what I'm saying, further, wherever you get the slope form, you can write the line equation directly. Okay, now let us move on to the problems in between. If you need more explanation, I will come on to the whiteboard. Okay, so let us check. The problems. The problems what I have chosen here for today's class. Just see this first question, please. First question. It is a simple question which can be understood. Those who are attending the class, please put your name in the chat box so that I'll be understanding how many of you are attending the class, and whatever the doubt you have, then I can answer that easily. Please place your name in the chat box, please. Yes, the question is like PSB, the median of the triangle with vertices P22 and Q6 minus 1 and R73. The equation of the line passing through 1 minus 1 and parallel to PS. Yes, please. What is yes here? So let us take the triangle. triangle PQR. P Q R, and the midpoint of QR, it is clear, it is 7 plus 6 by 2, because PS is the median, S is the midpoint, and it is midpoint of QR. What is the midpoint of QR? 7 plus 6 by 2, 13 by 2, comma, 3 minus 1 by 2, 1. 13 by 2, comma 1 is the median, please, PS. Now what is P here? 2, 2. What is PS here? 2, 2. Now find the slope of PS, please. Because we need that line equation which is parallel to 1 minus 1 and parallel to PS and passing through 1 minus 1. So slope of PS is equal to, I am writing directly this one, this is 1 minus 2 or 2 minus 1, whatever, 1 divided by 2 minus 13 by 2, 2 minus 13 by 2, minus 9 by 2. So it is minus 2 by 9, please. So the line equation will be, just now I taught you the shortcut, multiply numerator with x and denominator with y and change the sign in between, plus, and substitute the point. 2 into 1, I am writing because it is the beginning, I am writing that. 2 into 1 plus 9 into minus 1. It is minus 7. Is equal to minus 7. So your answer is 2x plus 9y plus 7 is equal to 0. 2x plus 9y plus 7 is equal to 0. Just tell me, is it visible to you all? Respond. Respond, please. Okay. This is the first question. Why I have taken this first question, and you have centers of the triangle with respect to the straight line. The centers of the triangle are very important, and among them the centroid, orthocenter, circumcenter, incenter, and centroid is the point of concurrence of medians. Centroid is point of concurrence of medians, and median is this one. Now just now we have got it. And orthocenter is the point of concurrence of altitudes. Circumcenter is the point of concurrence of perpendicular bisectors. And incenter is a point of concurrence of internal angular bisectors. Internal angular bisectors. Now the second question belongs to that only, the equation of the line bisecting perpendicularly the segment joining the points minus 4, 6 and 8, 8 is simple question, and we need the perpendicular bisector. What are the points given here? What are the points given here? Just to see that, the point given is, one is minus 4, 6 and other one is 8, 8. Now we need the perpendicular bisector. Perpendicular bisector of a line is that line which passes through the midpoint of the line segment and divides it in perpendicularly. Divides it into 2 equal parts, and it is perpendicular to the line segment. So this is always perpendicular. Why I have taken this? Because the case of circumcenter comes here. The case of circumcenter comes here. So let us see now. What is the midpoint? Midpoint is 8 minus 4 by 2, 2, 8 plus 6 by 2, 7, 2, 7. And what is the slope of this line? 8 minus 6. Slope, please, for your understanding. 8 minus 6, 2. 8 plus 4, 12. The slope is 1 by 6. And its slope will be minus 6 then. Then it's minus 6 by 1. Line equation. Line equation, please. Now you have to recognize this like this. Line equation will be, just now I told you the short form of it. Multiply numerator with x and denominator with y, that is 6y plus y, and minus is there, put plus here and substitute the point. 6 into 2, 12, 12 plus 7, 19. So 6 plus 2, 6 plus y is equal to 19. Option A is the answer. Why I am insisting on this one? Perpendicular bisector. While finding the circumcenter, circumcenter is the point of concurrence of perpendicular bisectors. When it is a point of concurrence of perpendicular bisectors, if you know how to write the perpendicular bisector equation, then you can find out the circumcenter directly. Okay, so this is what. The second question, please. This is what the second question. Okay, now third question. Next question, please. Next is a concept I have taken. The concept that is generally confused by the students I have taken. This is nothing but if the equation of a straight line is ax plus by plus c equal to 0. If the equation of a straight line is ax plus by plus c equal to 0, in order to select a point on it, take the x coordinate according to your sweet will. He used the word sweet will there. Whatever x you take, if you take x is equal to lambda, then a lambda plus by plus c equal to 0, or y is equal to minus a lambda plus c by b. Then the point can be taken as, what? Point can be taken as x is lambda and y is minus of a lambda plus c by b. This can be taken as a point. Okay, now let us see. Let us see an example on this one. The points on the line x plus y is equal to 4, which lie at a unit distance from the line 4x plus 3y is equal to 10. Now, let us use this concept here. X plus y is equal to 4. Then, let me write x as some a. Obviously, y becomes 4 minus a. So, a comma 4 minus a is your point. And according to the question, the point on the line which lies at a unit distance from the line. What is its distance? It is said to be unit distance. Means its distance is 1 unit from the line given. So let us find out the distance here. Perpendicular distance formula, please. Modulus of ax1, that is 4a, plus by1, 3 into 4 minus a. I am writing directly 12 minus 3a minus 10 divided by 5 is given to be what? 1 unit. Is given to be what? 1 unit. Now let us simplify this. 4a minus 3a and plus 2 is equal to plus or minus 5, because I removed the modulus there. You got a now. A is nothing but 3 and a is nothing but minus 5 minus 2 minus 7. You got 2 points now, 2 values for a. Now substitute here 3 comma 4 minus 3. 3, 1 is 1 point, and second point is minus 7, and if you substitute minus on your 11. So answer is A. 3, 1 minus 7, 11. What is the concept that is to be remembered? Sometimes in the problems, you will be given a line and you will be asked to find out a point on the line. When you get such cases, while choosing the point, don't generally take it as x1, y1. Don't take the point as x1, y1. If you take point as x1, y1, then you may be under the impression that x1, y1 are two unknown quantities, or two variables, but they are not two, but it is one, because that point lies on this line. That point lies on this line, and hence you have to make use of this concept while solving the problems. Okay, that's what I did. X plus y is equal to 4. I have taken a point point on the line x. I have taken a. Obviously, y becomes 4 minus a, and the perpendicular distance formula applied. Thereby, we have got a value. This way, a value is substituted. A value is substituted in this one to get the points. Okay, that is one more concept you have to remember. Okay, let's go to the next one. Point of intersection of the lines. Everyone knows this, because from your lower classes itself, solving two linear equations, everyone might have done. There are three methods there: elimination method, substitution method, and cross multiplication method, and all these methods are there. But everyone has their own style to follow. But what I'm suggesting you, while solving two linear equations in x and y, x and y, follow this short form. What I'm going to tell you to write the answer within one step. What is that? This everyone knows. This formula everyone knows, but never you apply this. But what I'm telling you, I'm telling you to apply this comfortably while solving two linear equations like this. Just observe the denominator here. What is the denominator? a1 b2 minus a2 b1. What is the denominator here? a1 b2 minus a2 b1. And when you are given two equations like this, simply follow this. Close the constant and cross multiply this. Close the constants and cross multiply this. How to remember? Top to bottom plus, and bottom to top minus. Top to bottom plus, bottom to top minus. This one, a1 b2 minus a2 b1. Fill the denominator. Then coming to the numerator of x. Close x then. Close x. What I mean to say by close x? Like this. Close this x. To write the numerator of x, close this x. I closed x here. Now to write the numerator of x, simple cross multiply the remaining. b1 c2 minus b2 c1. b1 c2 minus b2 c1. Everyone knows this cross multiplication method, but why I am insisting on this? Just you can write the answer straight. And to write the numerator of y, then cross multiply c1a2 minus c2a1. C1a2 minus C2a1. Let me take a problem, then you will understand in a better way. Let me write the equations, please. Let me take two equations. One is 2x plus 3y minus 1 equal to 0. Other one is 4x minus 2y plus 3 equal to 0. These are the two equations. What I am saying, if you want the point of intersection in this case, straight one step answer like this. This one is close constants and cross multiply this. Minus 4, minus 12, minus 14. and want the numerator of x, if you want the numerator of x, close x and cross multiply 9 minus 2, 7. And numerator of y, close y and cross multiply, not from left side but from right side. Not from left side but from right side. So minus 4, minus 6, it is again minus 7. Minus 4, minus 6, minus 10. Minus 10 please. That's all the answer. That's all the answer please. This is the point of intersection. So you practice this so that it will be Sai Tapasvi, good evening. So that it will be easy for you while solving the equations. See what is that I did. I have written this point of intersection within one step. One step I have taken the example. Also, that is the reason why I have taken this concept. B1 C2 minus B2 C1 by A1 B2 minus A2 B1 C1 A2 minus C2 A1 by A1 B2 minus A2 B1. How to remember? Two equations I have taken, and to fill the denominator, close constant and cross multiply and fill the denominator. And to write the numerator of x, close x and cross multiply, 9 minus 2, 7. And to write the numerator of y, close y and cross multiply, minus 4, minus 6. That's it. That's it. Remember that please. Remember that. And practice it. Now, let us move on to the next part of it. The equation of the straight line passing to the point of intersection of the straight lines and having infinite slope. Infinite slope. See, I am writing point of intersection directly. I am writing point of intersection directly, please. Let us write point of intersection directly. This is minus 6 plus 5 minus 6 plus 5 minus 1. Let us write the numerator of x, close x and cross multiply, minus 7 plus 4, minus 7 plus 4, minus 3. And then close y and cross multiply, not from left side but from right side. 2 into 5, 10, 10 minus 21, 10 minus 21, minus 11. So we have written the point of intersection within one step without applying any elimination method or substitution method or whatever. So now having infinite slope means, this is everyone knows, slope of x-axis is 0, slope of y-axis is undefined. Slope of y-axis is undefined. Everyone knows that. This is x, this is y, and we need the line equation which is having infinite slope, and the point we have got it to be 311. 311. That means I need a vertical line. I need a vertical line. Understand this. I need a vertical line. So the vertical line which is passing through 311 is nothing but x is equal to 3 please, whose slope is infinite. Similarly, the horizontal line may be asked. Then in that case, if the horizontal line is asked, then what is to be done? Then simple, the line will be like this, passing through 311. It is parallel to x-axis. This is origin, of course. This is origin. And the line which is parallel to x-axis, whose slope is 0? Whose slope is 0 is nothing but y is equal to 11. The question is given now in two different forms. First is infinite slope. Next is the slope. First is infinite slope will be parallel to y-axis. Next is whose slope is 0 is given to be y is equal to 11. This is the question. Simple question, please. Simple question. Everyone can understand that. Let us move on to the next question. Let us move on to the next question, please. Okay, that is angle between the lines. Very important concept. Very important concept. Tan theta is equal to m1 minus m2 by 1 plus m1 m2. Everyone knows that. Everyone knows that. And cosine formula. Cosine formula. Why I have not taken this? I want to write this and I want to remind you this. I want to remind you this. Cosine formula, which is very important because it will be extended even in 3D and vectors also. So your cos theta is equal to a1 a2 plus b1 b2 divided by root over a1 square plus b1 square into a2 square plus b2 square. Very important formula, please. How do you get this in three-dimensional geometry? In three-dimensional geometry, you will be getting it as cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root over a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square. Like that, you will get cos theta formula in 3D. And in vectors, how do you get it? It is nothing but a bar dot b bar in vectors. What is a bar dot b bar in vectors? Mod a bar, mod b bar, cos theta. So cos theta is nothing but a bar dot b bar by mod a bar into mod b bar. This is the formula, please, in vector algebra. The same vector algebra can be converted to three-dimensional geometry. In three-dimensional geometry, you will have extra z coordinate, which is a1 a2 plus b1 b2 plus c1 c2 by root over a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square. Now here, in this case, if they are parallel, see, if they are parallel, this is a condition. I'm clearing this. If these two lines are parallel, then C A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. The constants are not equal. The constants of proportionality is not equal, and hence the lines will be like this. Lines will be like this. Okay. If they are coincident, that means both lines are same, both the equations are representing the same line, then in that case, all are equal, that is all are proportional. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. If they are intersecting, obviously A1 by A2 is not equal to B1 by B2. Remember this. The same conditions, why I have taken this case here, the same conditions will be simply carried. Excuse me. The same conditions will be simply carried to three-dimensional geometry and vector algebra. In three-dimensional geometry, you will get A1 by A2 is equal to B1 by B2 is equal to C1 by C2 if two lines are parallel, and is not equal to D1 by D2 if they are is not equal to D1 by D2 if they are parallel. That means this will be continued with is equal to 3D condition. What is it? A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to D1 by D2. If they are coincident, is not equal, then they are parallel. If they are intersecting, A1 by A2 is not equal to B1 by B2 is not equal to C1 by C2. If they are perpendicular, very important condition is that A1 A2 plus B1 B2 equal to 0 in two-dimensional geometry. In 3D, you will get it as extra plus C1 C2 equal to 0. In vector algebra, simply it is A bar dot B bar equal to 0. Why I am insisting on this? You may be under the impression that these 2D conditions are different and 3D conditions are different, vector algebra conditions are different. No, not at all. Not at all. All the and the concepts from vector algebra to 3D and 3D to 2D, that will be more comfortable. That means you start seeing three-dimensional geometry from the window of vectors and start seeing 2D from the window of three-dimensional geometry. If you see like that, all the concepts will be very comfortable to you. And this is about the angle between the two lines, tan theta m1 minus m2 by 1 plus m1 m2, and cos theta formula. You must remember, because this formula will not be continued to 3D and vectors. The reason is you don't have slope concept in three-dimensional geometry. You don't have slope concept in vector algebra. Then how mathematician replaced the slope concept? Mathematician introduced DCs and DRs in place of slope. DCs are nothing but direction cosines. That is what the difference between them. That's the reason why cos theta formula will be continued, but not tan theta formula in 3D and vectors. Okay. Now coming to the next part is the equation of straight line which pass through a given point x1, y1 and make a given angle alpha with the straight line y is equal to mx plus c, or y minus y1 is equal to m plus or minus tan alpha divided by 1 minus or plus m tan alpha into x minus x1. Let us understand this slope first. If you understand slope, everything is done. If you remember this formula, that's good. Even if you don't remember also, I'm going to teach you the method. What is a data given here? The line is passing through x1, y1. So what is the point given? x1, y1. And make a given angle alpha with a straight line y is equal to mx plus c. What is the line given? Y is equal to mx plus c. It is making an angle alpha with this line. Now we need the equation of this line. This line equation is needed. Okay. Now apply. It's a slope we don't know. Let it be some m dash. Now when slopes are known to us, you can apply the angle formula. Tan theta is equal to m1 minus m2 by 1 plus m1 m2. What is it? Modulus of. Why should we use modulus here? Because we don't know whether it is acute angle or obtuse angle, and if you have whether acute angle or obtuse angle, that will be taken care by this modulus. So m is slope here, m dash is slope here. m1 minus m2 by 1 plus m1 m2. What is that we need? We need m dash there. So cross multiply 1 plus mm dash into tan alpha is equal to plus or minus m minus m dash. Okay. Now if you simplify there, you will get m dash. From this one, which is nothing but, you will get m dash from this one, which is nothing but this. Understand the concept, please. Understand the concept. What is that we did? A point is given on the line. And another data is given. What is it? That line is making an angle alpha with the given line y is equal to mx plus c. Now what we are doing, we are making use of that alpha there, and because point is given on the line and we need the slope, we have taken the slope as m dash. And we applied tan theta formula. Here tan theta, in place of theta you must have alpha, because the angle is given to be alpha there. So tan alpha is equal to modulus of m1 minus m2 divided by 1 plus m1 m2. The same formula utilized. the same formula utilized, and we have got m dash there. We have got m dash there. What is m dash? This one. This one is, you will get simplified. Simplifying m plus or minus tan alpha divided by 1 minus or plus m tan alpha. So after getting the slope, because you know the point x1, y1, you can write the line equation y minus y1 is equal to m into x minus x1. That's what he did. So I have explained you the procedure, and hence if you remember the formula, that will be great. Or even if you do not remember also, you must be in a position to apply or remember the method what I explained you. Let us see that. The equation to the lines passing through 3 minus 2 and are inclined at 60 degrees to the line root 3x plus y is equal to 1. If you make use of the formula, that will be great. Even if you don't also, no problem. Let us take the equation of the lines which pass through 3 minus 2. So let me take the slope of this as m. Okay, now the slope of this, you know, it is minus root 3. Let me apply tan 60. You need not have to apply modulus every time, but here you have to make use of it because tan 60 is always positive, which lies in the first quadrant. So m1 m minus m2 plus root 3 divided by 1 plus m1 m2, 1 minus root 3m. What is tan 60? It is root 3. So root 3 into 1 minus root 3m is equal to plus or minus m plus root 3. Plus or minus m plus root 3. So this is minus 3m. Let us take plus first. Bring that 3m to other side, minus 3m to other side becomes 4m, and it is root 3, and it is minus root 3 gets cancelled, m is equal to 0 you will get. And if you take minus, you know, this is minus m, this is minus 3m, and bring this to other side, 2m is equal to minus root 3, bring this to other side, minus root 3. This is 2 root 3. So you got m value root 3, m value 0. M value 0 means parallel to x-axis. Parallel to x-axis and passing through 3 minus 2. What is it? Y plus 2 equal to 0. And here only one option there. Y plus 2 equal to 0. Let us see with the short form what I taught you. Root 3 by 1 slope. Multiply numerator with x, root 3x. Multiply denominator with y, 1y. Change the sign, whatever plus sign is there, change the sign in between, minus, and substitute the point now. Substitute the point, 3 root 3, my plus 2. So that's what is the answer. That's what is the answer. So, let me repeat this. The same concept, what we have learned previously. I have not used the formula. We have just used the concept only. What is the concept here? The line equation is needed on which a point is given to be 3 minus 2, whose slope is not known to us. We have taken the point, we have taken the slope as m. We have taken the slope as m, and that slope is m, and the given line slope is minus root 3, and tan theta formula we know m1 minus m2 by 1 plus m1 m2, and the angle is given to be 60 degrees. I applied that, and don't forget to put modulus there because it is 60 degrees. Okay, now we have taken, before removing modulus, we have taken plus or minus, and we have got two values for m. M is 0, m is root 3, and hence these two lines we have got y plus 2 equal to 0. Root 3x minus y minus 2 root 3 minus 2 minus 3 root 3 is equal to 0 is the answer for that. Okay. Now, next question please. In an isosceles triangle ABC, B and C are given. What is B? 1, 2. What is C? 2, 1. And the equation of AB is given. This is A. This is AC, that is AB, this is AC. This is nothing but A, please. Equation of AB is given to me, y is equal to 2x. We need the equation of AC now. We need the equation of AC. Let us find out the slope of this. 1 minus 2 minus 1. Its slope is minus 1, please. Its slope we don't know. And it is given that it is an isosceles triangle. That means these two sides are equal. And this angle is theta. This angle is also theta because it is an isosceles triangle. Now apply tan theta formula. Apply tan theta formula. Tan theta is equal to m1 minus m2. That is, its slope is 2 here. 2 plus 1 divided by m1 minus m2 by 1 plus m1 m2, that is 1 minus 2, 2 into minus 1. Must be equal to, we need the slope of this because C we know, and if you know the slope of this, you can write the line equation. So that's the reason why I have taken the slope of this line AC as m. Now apply the formula here. m1 minus m2, that is m plus 1, divided by 1 plus m1 m2, 1 minus m. Okay, now put a modulus here. Both are tan theta only. Why? Because it's an isosceles triangle. Now it is minus 3. So m plus 1 is equal to plus or minus, this is minus 3, no? I am removing modulus. 3 into 1 minus m. Now take plus minus 3m, bring it to other side, 4m. And it is plus 3 minus 1, 2. So m is equal to 1 by 2. Check the answer now. M is equal to 1 by 2. What is the point given? 2, 1. 2, 1. Slope is 1 by 2. Slope is 1 by 2. Apply the short form, what I taught you. What is the short form? Short form, please. Numerator x, denominator y is equal to, substitute the point here. What is the point? 2, 1. 2 minus 2. Because we need the line equation AC. 2 minus 2, 0. So this is the line equation, y is equal to x by 2. Y is equal to x by 2. Someone is saying good night. Yes, you can sleep very well. Good night, please. So this is x minus 2y equal to 0 is the answer. Next question. Line equally inclined with two lines. This is also an important concept. Check it here. This is the line. Here the angle is theta. This angle also theta. Okay, that means this line is making equal angles with these two different lines, M1 and M2. M1 and M2 are their slopes. First line slope is M1, second line slope is M2. Now, this angle is given to be theta. Now, this is tan theta, this is also tan theta. But, you must take care of the direction. What I mean to say by direction, while applying the formula, just apply like this. This must be taken in the same order. M1 minus M by 1 plus M1M. And the same order to be continued is equal to, just check, M minus M2 by 1 plus MM2. 1 plus MM2. That's what you have to understand. Okay. Now, so what is that? He has given it like this, but you can remember in the same direction. What is the direction? M1 minus M divided by 1 plus MM1 is equal to same direction. M minus M2 divided by 1 plus MM2. Because M1, M2 are given, M1 given, M2 given, you can find out M from this one. This is also an important one to be remember. To be remembered. Next, based on this, the question please. Based on this, the question. If the lines are equally inclined to the line, y is equal to mx plus 4, then m is equal. Okay. Let us do the same, what we have learned. Here itself, let us understand in the diagram. What is M1? M1 for the first line is 3. M2 for the second line. This one please. Minus, it is 1 by 2. M1 given, M2 given. Now you have to find out M. This is M here. This is M. Simple. Apply this now. 3 minus M. Divided by 3 minus M divided by M minus 1 by 2. Just a moment please. This is M1 is 3, M2 is 1 by 2. M means this is the line. Now, apply the formula. 3 minus M divided by 1 plus 3M is equal to M minus 1 by 2 divided by 1 plus M by 2. 1 plus M by 2. Okay. Someone answered, this is Shiva, 1 by 2. Yeah, that should be the answer, but here the options are seem to be different. I don't think one of this is wrongly placed options. Let me finish this. 3 minus M into 2 plus M is equal to 2M minus 1 into 1 plus 3M. That means you will get a quadratic here. By solving this quadratic, I think you will get two roots. One of them, someone answered, is 1 by 2. Let me write that. 6 minus 2M plus 3M plus M minus M square is equal to plus 2M minus 3M minus M, and it is 6M square minus 1. So what is it? 7M square Just see that. Let us solve this. Seven m square. Here. 7m square plus 2m. And constant please. Minus 7 is equal to 0. This is what we have got. Okay. So that means that 1 by 2, I don't think you'll get it. Let me write that now. M is equal to minus b plus or minus root over b square minus 4ac. That is, b square means 4 plus 49 into 4. 196 by 14. So minus 1 plus or minus 200, no? It is, you'll get 4 common, 50 you will get, root 50. How plus 2m? Huh? Someone is asking how plus 2m? Huh? This is minus m. Oh, you're right. 7m square minus 2m. You're right, you're right. That's good. Now I'm happy that someone is following. 7m square minus 2m plus 7. Okay. Now solve it, please. By solving this, let us check which answer satisfies. Can you try that? That's right, Raghav sir. I corrected it. Minus 2m. That's good. Anyone, do you tell me the answer by applying the quadratic formula, please? By applying the quadratic formula. Shiva, do you tell me the answer? Minus b plus or minus root over b square minus 4ac by 2m means 14. So it becomes 1 plus or minus root yeah, please do it. $200 means under root 200 is 25 into 8. It's 2 root 50. 2 getting cancelled by 7 you'll get 5 root 2. This one should be the answer. Yeah. That's good, Shiva. You are good even in typing roots also in the chatting. Very great. Where from are you, Shiva? This is also a very important concept in straight lines. Equations of bisectors of angles between two straight lines. Equations of bisectors of the angles between two straight lines. because this concept is important. Let me explain it on the board. Let me explain it on the board. See here. This one, angular bisectors. In fact, the pair of straight lines is not there in IT JEE syllabus, but this pair of lines concept is there in the board level. And even though in the syllabus of JEE, pair of straight lines topic is not named directly, but pair of straight lines is oh, Shiva from Jayendra. Okay, I remember Shiva. Good. So pair of straight lines concept, even though it is not there in JEE syllabus, pair of lines is nothing but two lines. That's the reason why the questions related to pair of lines may be given in the JEE examination, but the formulas straight away related to pair of straight lines will not be used. Why I am taking the context of that, here the pair of lines, the angular bisectors, whatever I am going to derive, will be utilized in pair of lines also. So now, this is one line, this is another line. These are the two lines. One line is a1x plus b1y plus c1 equal to 0. Other line is a2x plus b2y plus c2 equal to 0. Other line is a2x plus b2y plus c2 equal to 0. The property what we are using now to get the angular bisectors is very important. What is that? Let us suppose this is the acute angle bisector. Let us suppose this is obtuse angle bisector. This is, let me say, acute. This is obtuse. Let me say. Okay, whatever the angular bisector you take now, whatever the angular bisector you take, you choose any point on the angular bisector. Its distance from the two lines will be equal always. What does it mean? If you take a point here now, for example, I have taken a point P x0 y0. Now, if you take the perpendicular distance, PA is equal to PB. PA is equal to PB or equal. Okay. So, PA is equal to PB. What is the property that is to be remembered? Any point on the angular bisector. Any point on the angular bisector is always equidistant from the two lines. So here, PA, perpendicular distance formula, A1 x0 plus B1 y0 plus C1 divided by root over A1 square plus B1 square is equal to, modulus will be there always, modulus of A2 x0 plus B2 y0 plus C2 divided by root over A2 square plus B2 square. I hope you understand that. What is that I did? Perpendicular distance formula. Everyone knows that formula. Now, x0, y0 is a point on the locus we have taken. That's why I insisted while explaining you in the previous sessions x naught, y naught, I have taken as a point on the locus, and finally I converted it as xy. But some problems I took directly xy directly, and why I suggest you to take the point on the locus as x naught, y naught. If I take it as xy, while writing the perpendicular distance, you may be getting doubt. This is xy, this is also xy. This is xy, this is also xy. If you don't have the confusion, take it as xy, no problem. But if you take it as x naught, y naught, it will be clear. So finally, what are the equations of angular bisectors? Now convert x naught, y naught as xy. That is, we are generalizing. We are generalizing the equations now. That is a1x plus b1y plus c1 divided by root over a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 divided by root over a2 square plus b2 square, please. Why plus or minus? Because we are removing modulus there. We are removing modulus, and hence we wrote it as directly as plus or minus. By taking plus, you will get one angular bisector. By taking minus, you will get another angular bisector. But whether by taking plus you will get acute angle bisector or obtuse angle bisector. By taking minus, whether you get acute angle bisector or obtuse angle bisector, we don't know that. Generally, in the board level, this concept, you will not have any questions in the board level. But for the objective examinations, it is given more importance. How to find out the acute angle bisector and obtuse angle bisector. How to find out the acute angle bisector and obtuse angle bisector, and by simply applying this formula, you will get both angular bisector. We get both angular bisector by taking plus one angular bisector, by taking minus another angular bisector. Now, let us understand how to decide that. See here, please. Whenever to decide acute or obtuse, see here, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Never forget this point. Your c1 comma c2 must be greater than 0 always. Your c1 comma c2 must be greater than 0 always. What does it mean by greater than 0? Greater than 0 means if it is not, if one is positive, other one is negative, or both are negative, then what is that to be done? You have to make it positive always. You have to make it always positive. How? For example, I'm taking an example for a better understanding. For example, there is a line like this, 2x plus 3y minus 1 equal to 0. Another line is there, 5x minus y plus 7 equal to 0. Then you should not apply whatever the condition I'm going to explain directly without making it plus. So to make it plus, what is to be done? Multiply with minus. Then what happens? Minus 2x minus 3y plus 1 equal to 0. Then apply this condition. Remember that. Your C1 comma C2 must be greater than 0. Then, for acute angle bisector or obtuse angle bisector, you have to always find out the value of A1, A2 plus B1, B2. There is a proof for it, we don't need it. We have to take A1, A2 plus B1, B2. Value of A1, A2 plus B1, B2. If it is greater than 0, then minus gives you acute angle bisector and plus gives you obtuse angle bisector, please. Are you with me what I am saying? A1, A2 plus B1, B2 greater than 0, minus gives you acute angle bisector, plus gives you obtuse angle bisector. If it is reversed now, A1, A2 plus B1, B2 less than 0, then plus gives you acute angle bisector and minus gives you obtuse angle bisector. So What is step 1 you have to remember in this case? Step 1. Step 1. Make C1, C2 greater than 0 always. Step 2. Find out A1, A2 plus B1, B2. If you find out A1, A2 plus B1, B2, if it is positive, by taking minus here, you will get acute angle bisector. By taking plus here, you will get obtuse angle bisector. And if A1, A2 plus B1 is less than 0, by taking plus here, you will get acute angle bisector. By taking minus here, you will get obtuse angle bisector. That means, you can observe that whatever the sign of A1, A2 plus B1, B2 is there, that will be same sign for obtuse angle. I repeat. Whatever the sign is there for A1, A2 plus B1, B2, the same sign is there for obtuse angle. Obviously, the other one becomes acute angle. Okay? Now, similarly, containing the origin is also there. Find the angular bisector containing the origin. What does it mean? For example, origin is lying here. Then we say that acute angle bisector is containing origin. If origin is here, then we say that acute angle bisector is containing the origin. If origin is lying here, then we say that obtuse angle bisector is containing the origin. The same process for this also. For this also same process, just this will be reversed. That will be reversed. Containing the origin is got by, we will see that again in the notes. I will show you that again. A1, A2 plus B1, B2 greater than 0, then plus will give you the origin containing the angular bisector containing the origin. The angular bisector containing the origin is got by, if it is greater than 0, plus 1. Then minus will give you not containing the origin. The same concept. Okay. This is about the angular bisectors. This is about angular bisectors. So I'm going for the example now. Someone said this is Srini. I'm coming for the example now. I'll show you the example for this. Okay. Let us see that. So if you have any doubts now, you can place your doubts in the chat box, or otherwise you can take only WhatsApp voice call to this number 8699924999. 8699924999, and you have the WhatsApp doubts group for this one. You can send a request to this number to join the doubts group, and from in that group your doubts will be clarified if you post it. If you in the live, if you want to talk, if you want to ask any doubts, the voice call. If your doubt is not clarified through the chat, then you can call this number 8699924999. Now, let us see this. Equations of the bisector of the angles. This is what I derived. Okay. This is what I derived. This is A1x plus B1y plus C1 by root over A1 square plus B1 square is equal to plus or minus A2x plus B2y plus C2 divided by root over A2 square plus B2 square. So algorithm to find the angle containing the origin. Origin, just now I said that you have to keep always C1, C2 greater than 0. It is not mentioned here. To find the bisectors of the angle containing the origin, we proceed as okay. It is given step 1 C1, C2 in the equations. Let it be positive. Make them positive. If they are not both are not positive, then make them positive. Step 2. Now obtain the bisector corresponding to the positive sign, that is plus. Plus contains the origin. The angular bisector containing the origin. This is a required bisector angle containing the origin by taking plus. A1, A2 plus B1, B2 greater than 0. Okay, to find the acute obtuse angle bisectors, this is a different method given by finding tan theta. If tan theta less than 1, it will be less than 45 degrees and double of it will be less than 90. Like that also we can do. If tan theta is greater than 1, no, it will be greater than 45 and thereby it will be the obtuse angle bisector. Like that also we can do. Okay, now this is the method I explained you. Make the constant term positive if not. Now determine the sign of the expression a1 a2 plus b1 b2 a1 a2 plus b1 b2 greater than 0. Then minus sign gives you acute angle. If it is less than 0, then plus sign gives you the acute angle. Okay, that's what it is. Now someone asked for the example. Srini asked for the examples here. This is the equation of the bisector of the acute angle between the lines. Equation of the. Now check first of all whether the signs of the constants are equal or not. No. No. Just see. This is positive and this is negative. So you have to make it positive. 3x minus 4y plus 7 equal to 0. It is minus 12x minus 5y plus 2 equal to 0. Now a1 a2 plus b1 b2 is equal to minus 36 plus 20 is minus 16 less than 0. What is that we need? We need the equation of the bisector of acute angle. Acute angle reverse sign. Acute angle reverse sign. What is it? 3x minus 4y plus 7 divided by 5 root of 3 square plus 4 square 5. You got negative here, that is why you have to take plus for acute angle. Take the equation minus 12x. Take this equation only. Plus 5y plus 2 divided by 13. Can you simplify and tell me the answer, anyone? Anyone please? Yes, Ravi Babu sir, that's what I explained the concept and then I have taken an example. But whatever you are suggesting also good. Problem discussed through synopsis. I will plan like that further. Anyone please? 39x minus 52y Yes, Srinivas, what is the answer? 91 is equal to minus 60x plus 25y. No, this is minus, I think. Minus 25y. Yes, minus 25y plus 10. What is the answer? 99x is there. $99x plus 20 minus 27y Divide with 9, then you will get 11x minus 3y. Only one option there. This one is also there. Plus 9 minus 9 is there. And constant is 91 minus 10 plus 81 equal to 0. So this is the answer. Follow please. No one answered it. You got D now? It's not D, I think it is B. Check it out. Check it out, please. It should be B. Check Srinivas. Correct. That's right. Now, this is what the concept is. The same question can be asked even for obtuse angle. If it is asked for obtuse angle, apply the same conditions, make these two positive always, and after that find out A1, A2 plus B1, B2. In this case, if you want obtuse angle, you know, for the obtuse angle, for acute angle, you are taking plus. For obtuse angle, you take minus. That's it. That's it, please. Okay. Now, let's move on to the next concept. Length of the perpendicular. I'm not going to derive this because everyone knows this. Modulus of ax1 plus b1 plus c by root over a square plus b square. Perpendicular distance from the origin is mod z by root over a square plus b square. So this is perpendicular distance from x1, y1 to the line, and this is perpendicular distance from origin to the line, and this is the distance between the parallel lines. Distance between the parallel lines. Importantly, is d is equal to modulus of c1 minus c2 by root over a square plus b square. What I am insisting, you know, the same perpendicular distance formula you will get again in 3D. 3D perpendicular distance formula modulus of ax1 plus b1 plus cz1 plus d by root over a square plus b square plus c square. And distance from the origin. That means here this is a line, in 3D it will be the plane. Here it is a line, in 3D it will be the plane. Why? All the concepts of straight line are extended to 3D plane. The reason is line is made up of points and plane is made up of lines. Line is made up of points and plane is made up of lines, and hence while we are talking about two planes, we call it as line of intersection of planes. And hence all these concepts will be straight away transferred to 3D plane. 3D plane. Perpendicular distance here, there, perpendicular distance from a point x1, y1, z1 to the plane ax plus by plus cz plus d equal to 0 is modulus of ax1 plus b1 plus cz1 plus d1 by root over a square plus b square plus c square. From the origin, here it is mod c by root a square plus b square, there it is mod d by root over a square plus b square plus c square. And the distance with the parallel line is modulus of c1 minus c2 by root over a square plus b square. There, in the planes, it is modulus of d1 minus d2 by root over a square plus b square plus c square. So extra, you will get one thing extra here. Okay, now let's move on to the next concept. Position of 2 points with respect to line, please. This formula is not given here. Of course, I'll write it. This formula related to this is a simple formula. What is it? This is a line. And this line is given by ax plus by plus c equals 0. There are 2 points here. One is x1, y1. Other one is x2, y2. Just for derivation sake, I have taken the points on either side of the line. And we want to understand whether these 2 points are lying on the same side of the line or opposite sides of the line. These are the 2 points. And this is the point of intersection P, please. We don't know in which ratio the line divides the line segment, and hence we take the ratio as lambda is to 1. And hence we take the required ratio as lambda is to 1. And we apply the ratio formula lambda x2 plus x1 by lambda plus 1, lambda y2 plus y1 by lambda plus 1. And P we have got on AB, but this P lies on the line also. By simplifying this, you will get lambda as minus of x1 plus by1 plus c divided by ax2 plus by2 plus c. ax2 plus by2 plus c. Okay, so this is nothing but, to remember this easily, we call this line as L, and simply we will be remembering this formula as minus L11 by L22. No confusion there. Minus L11 by L22 means substituting the first point in the line, L11, substituting the second point in the line, L22. So the formula is minus L11 by L22. Let me form a question here so that you will better understand it. What is the formula? Remember, minus L11 by L22. Okay. Let me form a question. Let me write a line equation here. 2x plus 3y minus 7 equal to 0. Let me take 2 points here. Minus 1, 2. Minus 3, minus 5. Our interest is whether the 2 points are lying on the same side of the line or opposite sides of the line. Our interest is whether these 2 points are lying on the same side of the line or opposite sides of the line. Then this formula is to be utilized. Minus L11 by L22. So what is the concept here? Minus of 2 into minus 1, minus 2, 3 into 2, 6, minus 7, divided by minus 6, and it is minus 15, minus 7. It is 4 minus 7 minus 3, minus of minus 3 plus 3, divided by, it is minus 21 minus 28. You have got the ratio negative. Very important. You have got the ratio negative. You have got the ratio negative means they lie on the same side. That's correct, right, officer? If ratio is positive, they lie on opposite sides. If the ratio is negative, they lie on the same side. And this problem, what I formed here now, the 2 points lie on opposite sides. If you want more explanation for that, this is the line. This is the line. And the 2 points will lie on the same side, like this. This is a line segment. See, what is it happening? This is A, this is B. Now, these 2 lines are not directly intersecting with each other. It is intersecting it externally. That's what you have to understand. It is intersecting it externally. So, because it is externally, we have got the ratio to be negative. So, if you get the ratio negative, we say that the 2 points lie on same side of the line. If you get the ratio positive, you will say that The 2 points lie on the same side of the line. Okay. Now, let us see there is a problem on it or not. This is a different question. Please try that. It is easy. The point on x-axis whose perpendicular distance from the line x by a plus y by b is equal to 1 is perpendicular distance is given to be a. Yes. Professor, you said the same in 3D also. Same in 3D also means what? The same line will be taken as plane there. You will have a plane and there you have to talk about the points, whether the points are lying on same side of the plane or opposite sides of the plane. All the concepts of line will be just transferred to the plane. Now here, the point on x-axis is saying let the point be x comma 0. Now, write the perpendicular distance please. It is given to be a. Apply the perpendicular distance formula modulus of x by a. To avoid any confusion, take it as x naught otherwise. You may be getting confused if both are x. That is why I changed it as x naught. I need x naught now. X naught by a minus 1 divided by root over 1 by a square plus 1 by b square. Okay, now simplify this to get x naught. What is that? A into root over a square plus b square by ab. Brought it outside the root. Okay, is equal to 1 by a into modulus of x naught minus a. This is to be simplified. From this one, you get x naught is equal to, transfer this a to other side, a by b, remove the modulus, a by b into, this is plus or minus you will get if you remove the modulus. Okay. Check the answer please, anyone. Please tell me the answer. I gave you the entire working there. Anyone? Please tell me the answer. So x naught minus a is equal to plus or minus a by b into root over a square plus b square. So x naught is a plus or minus a by b, a plus or minus this one. Option C please. Option C. I hope you understand that. Next question. The vertex of an equilateral triangle is 2 minus 1 and the equation of its base is x plus 2y is equal to 1. The length of its sides is. The diagram also given here. Vertex is given to be 2 minus 1. The equation of the base is x plus 2y is equal to 1. Then you have to find out the length of its sides. Let the length of the side be a. Find the perpendicular distance, please. I am writing directly because everyone knows the perpendicular distance formula. Modulus of ax1, 2, minus 2, 0, minus 1, modulus of minus 1 by root 5. So 1 by root 5 is the perpendicular distance. Now you know opposite side and we need hypotenuse. Find out sine 60 is equal to opposite side by hypotenuse. So your A is equal to 1 by root 5, 1 by root 5 into 2 by root 3. 2 by root 15 should be the answer. This is the answer. Which recap you need, Srinivas? Which concept recap? This is the vertex given 2 minus 1, the base baseline equation is given x plus 2y minus 1 equal to 0, and perpendicular distance from 2 minus 1 to this line, we are going to be 1 by root 5 by using the formula modulus of ax1 plus b1 plus c by root over x square plus b square, which is 1 by root 5, and because the opposite side to 60 degrees is known to us and we need the hypotenuse, the trigonometric ratio relating opposite side and hypotenuse is sine 60 is given, and from that one you have got A. A is nothing but the length of the side of the equilateral triangle. Whenever you do not understand something, you replay the video, and thereby you can revise the concepts. Next, please. Concurrent lines. Set up concurrent lines. This is also an important concept. Set up concurrent lines is three or more lines are said to be concurrent lines if they meet at a point. At a single point, if they meet, then we call them as concurrent lines. Three lines are said to be concurrent if they meet at the same point. This is one line, another line, this is another line. These are the three lines. Okay. If they meet at the same point, if they meet at the same point, then the determinant becomes 0. Or otherwise, what is the concept that you should not forget is solve any two lines and substitute that point of intersection in the third line. If this point of intersection is satisfying the third line, then we call them as three concurrent lines. Then simply we call them as three concurrent lines. Okay. Now here, very important thing that is to be remembered and given preference in the objectives. Given preference in the objectives is the set of concurrent lines. Is the concept of set of concurrent lines. I'll explain it. Just a moment. What is this? Set of concurrent lines. Very important, please. Very important even for the advanced examination also. That is, whenever you take two lines, one is L1 equal to 0, other one is L2 equal to 0. Other one is L2 equal to 0. Then these two we have taken as two non-parallel lines. These two we have taken as two non-parallel lines. These two non-parallel lines means definitely they will intersect at a point P. Then how many lines will be passing through? How many lines will be passing through this point of intersection? Infinitely many lines. Do you know? How many lines will be passing through? One line like this, other line like this, one more line like this, one more line like this. How many such? Many will be there. Many will be there. Is there any concept or is there any combined equation of all these lines? Yes, there is. That is said to be set of concurrent lines. Set of concurrent lines equation is simply given by L1 plus lambda L2 equal to 0, or it can also be written as lambda 1 L1 plus lambda 2 L2 equal to 0. Lambda 1 L1 plus lambda 2 L2 equal to 0, or L1 plus lambda L2 equal to 0. Both are same, please. Both are same. Why both are same? I'll tell you. For example, two L1 plus 3 L2 equal to 0 there. I will divide it with the 2. Then this is and these are same. This is nothing but lambda. So make use of this. Even if it is given also, make use of this. L1 plus lambda L2 equal to 0. So what is the commonality of all these lines? All these lines will be passing through the point P. All these lines will be passing through the point P. So L1 plus lambda L2 equal to 0 is the equation of the set of concurrent lines. And similarly, three lines equation can also be taken like this. Three concurrent lines equation can also be taken like this. Lambda 1 L1 plus lambda 2 L2 plus lambda 3 L3 is equal to 0. This is also a very important concept, please. I will tell you an interesting question on this concept. I will tell you an interesting question on this concept. Lambda 1 L1 plus lambda 2 L2 plus lambda 3 L3 equal to 0. Lambda 3 L3 equal to 0. Then if such condition is satisfied, then L1, L2, L3 are said to be concurrent lines, provided at least not all lambda 1, lambda 2, lambda 3 are zeros. Not all lambda 1, lambda 2, lambda 3 are zeros. Okay. Now, let me show you a question here. which is related to this, which is related to this. See here. See that. I'm writing a question here. B minus C. What I do now, I'll explain you how, if you understand, if you understand how the concurrent lines are formed, if you understand how the concurrent lines are formed, you will be more confident. See, whenever a professor wants to form a question, he must also have a base. He must also also have a concept to form the question. So, what is a concept that is followed by the professor to form three concurrent lines? I'll tell you like this. Just see. Just see. I'm taking two lines here. 2x plus y minus 3 equal to 0. Taking another line. 3x minus 2y minus 1 equal to 0. See, what is that I did? I have taken a point 1, 1 here. 2 plus 1, 3 minus 3, 0. I have taken 1, 3 minus 2 minus 1, 0. So, I have taken their point of intersection as 1, 1. Remember, I have taken their point of intersection as 1. Now, what is my interest here? I want to form such a line. I want to form such a line which is concurrent with these two lines. I want to form such a line which is concurrent with these two lines. Then simply you add them. 5x minus y minus 4 equal to 0. What is their point of intersection, please? What is their point of intersection? I have formed the equation by taking the point as 1, 1. Now, I said this third line is also concurrent with these two lines, and what is the operation I did? I have just added them. Check whether 1, 1 is satisfying this or not. 5 minus 1 minus 4, 0. Satisfying, please. It's satisfying. What is the operation I did? I just added them. That means what is that I did? L1 plus 1 into L2 equal to 0 I did. Then you may be thinking, sir, why not minus 1 into L2? Yes, do it. Do it. Let us subtract that. Let us subtract. Minus x plus 3y minus 2 equal to 0. Substitute. Minus 1 plus 3 plus 2 minus 2, 0. Satisfying. Okay. Then you may be saying, sir, why not L1 plus 2L2 equal to 0? Yes, you will get that also. Just see. 2L2 means multiply this 6x plus 2x, 8x. Multiply this minus 4y plus y minus 4y minus 3y. Multiply this minus 2 minus 3 minus 2 minus 5 is equal to 0. Check it out. 8 into 1, 8 minus 3 plus 5 minus 5, 0. Satisfied. So what is the concept here? What is the concept here? By varying the value of lambda using the two line equations, this is L1, this is L2, I have formed many lines here by adding them, by subtracting them, by multiplying one line with two, and I added, and all these lines are concurrent with this line. So, whatever the concurrent lines concept is there, concurrent lines are formed like this using this concept. Similarly, what I mean to say here, L1 plus L2 plus lambda 1 L1, let me say this has L3. Then what happens? L1 plus L2 minus L3 equal to 0. Check it out. L1 plus L2 means 2x plus 3x minus 5x. Cancel. y minus 2y minus y plus y cancel, minus 3 minus 1 minus 4 plus 4 cancel. So if you can get such a relation, no, between three lines, if you can get such a relation, no, between three lines, then you can confirmedly say that those three lines are concurrent. Those three lines are concurrent, please. So Samay garu, why are you praising me like that? So what is that? What is that? You have to understand here. What is that you are understand here? See, if you have three lines that are concurrent, then definitely you will have a linear relation between them. Lambda 1 L1. Definitely you will have a linear relation between them. Lambda 1 L1 plus lambda 2 L2 plus lambda 3 L3 is equal to 0. So I'm giving you a question now. B minus C into X plus C minus A into Y plus A minus B equal to 0. Let me say this as L1. C minus A into X plus A minus B into Y plus B minus C is equal to 0. Let me say this as L2. A minus B into X plus B minus C into Y plus C minus A is equal to 0 is L3. Then the question is given in the options like this. These are collinear. No, these are concurrent. These are non-concurrent. These are parallel or these are perpendicular. Something like that. The question is given. Something like that. The question is given. Then you should not think like this. What is that? Let us solve these two lines and let us substitute the point in the third equation. It will be very lengthy if you think like that. See, whenever it is given in the abstract form like this, what I mean to say by abstract form, it is given in the terms of ABC instead of numericals. Then definitely there will be a short form to prove this. So it is very clear that L1 plus L2 plus L3. What is it? Do you respond, anyone? Anyone, do you respond? 1 into L1 plus 1 into L2 plus 1 into L3. Anyone, please? Anyone, I expect the answer from you. Yes, they are concurrent. Why? By adding them, you are getting 0, please. By adding them, you are getting 0. And hence, you can say that those lines are concurrent without solving anything. At a glance, you can say that. You can say that, of course, the lines are given in the symmetric form, what Ravi sir is saying. B minus C minus A minus B. I gave the equations like their sum becomes 0. And hence, for this type of problems, you can close your eyes and you can say straight. You can say straight that they are concurrent lines. Okay. Now, here also the question, please. The ax plus by plus c equals 0, bx plus ay cy plus a equals 0, cx plus ay plus b equals 0 be concurrent. Then what is the condition? This is, you write straight away the determinant, please. ABC, BCA, CAB is equal to 0. Then you will get the determinant of it as this one. Better you remember that as a standard result, please. The determinant of it is AQ plus BQ plus CQ minus 3ABC is equal to 0. So the answer is option C. Next question. The straight line 4ax plus 3by plus c equals 0, where a plus b plus c is equal to 0, will be concurrent if the point is. Will be concurrent if the point is. This is also a good question. You have good number of previous questions on this concept. You have good number of previous questions on this concept, please. I'll give you the method, and after that I'll give you the short form also. What is the method? See here, please. This is 4ax plus 3by. C is nothing but minus a minus b equal to 0. Take a common. 4x minus 1 equal to 0. 4x minus 1 not equal to 0. 4x minus 1. B common. 3y minus 1 equal to 0. That's all now. Lambda 1 L1 plus lambda 2 L2 equal to 0. So by solving L1 and L2, you'll get the point of concurrence. So solve them. Solve, please. X is 1 by 4, Y is 1 by 3. That's it. That's it, please. This is the understanding. This is the method to get the point of concurrence. 1 by 4, 1 by 3 is the answer. And what is the other method? What is the other method, please? Let us check. Very simple. Here you have A, here also you have A. Here you have B, here also you have B. Here you have C, here also you have C. Just compare the coefficient, that's it. Coefficient of A. Coefficient of A is 4x here. Coefficient of A 1 here. Coefficient of B 3y here. Coefficient of B 1 here. Coefficient of C 1 here. Coefficient of C 1 here. That's all. You'll get x comma y now. 1 by 4 comma 1 by 3. That's it. This is a short form of doing it. This is short form of doing it. B answer. Trial and error method means it's not possible. No, Samegaru. So this is based on the concurrent lines. Concurrent lines concept, please. Next, reflection on the surface, foot of the perpendicular, and all this. See, I have collected almost 40 problems on this one. Because simultaneously I am discussing the concepts also. It is taking more time. Okay. There are only 11 problems or 12 problems we finished, and totally I have taken 40 problems to discuss. The rest of the problems we'll discuss in the next session, and previous problems also simultaneously I'll be collecting and I'll present those problems. See, it is a sort of revision of what I'm doing. Straight line concepts, along with the questions, a sort of revision, and after all the concepts are finished, we will go through the previous questions. Okay, after doing some topics like this, finally we'll go for the grand test papers. Grand test papers also I'll discuss. Okay, see you in the next session by the same time, 8:30 to 10:30 every day, 8:30 p.m. to 10:30 p.m. If you have any doubts, you join that. Send me a request to that group 8699924999, and I'll make you join in that polymath, try your math doubt group. And if you have any doubts, I'll clarify that. And in the session time also, in the live also, if you have any doubts, you can call that number, only WhatsApp call, and I'll answer that doubts, whatever you ask. Okay? See you in the next session. Namaste.